So what we're going to look at now is calculating a probability based on data. We're going to use the same rule where we take the number of outcomes for the event and divide by the total. We're just going to be using collected data to find that information rather than a sample space. So notice in the example that we have here, we have 10,000 families and they are broken down into these 4 different categories. We want to know first, what is the probability that a sampled family, like if we select one, owns their house? Okay, so you know first, right? You want to look at the number of outcomes for the event, right? That event is right here. And you want to divide that by the total number of outcomes. In this case, they told us, right, that the total number of families was 10,000. But notice if you did not have that information up front, you could just add up the number of families in each group, and you would get a total of 10,000. All right, so depending on how you're asked to input your answer, we're going to go ahead and convert this to a decimal, and we're going to report our probability as 0.4753. All right, if I want to look at a different event, what is the probability that a family rents? Notice in this case it doesn't specify house or apartment. So we're going to have to put those two together to get the number of outcomes for the event. 912 rent a house, 2,857 rent an apartment. That gives me 3,769 families that rent. And once again, I'm just going to divide by that total. All right, what we're using here when we talk about calculating probabilities based on data is something called the law of large numbers. And this just basically says if you repeat an experiment a large number of times, take for example flipping a coin, right? Every time we flip a coin, there's not going to be an exact 50% chance, right, that we get heads or we get tails. In other words, it might be that we get 5 heads in a row and then we get 3 tails in a row. But what the law of large numbers says is if we were to repeat this experiment a large number of times, say we flip the coin 100 times, when we do that and we repeat the experiment a large number of times, we're going to get very close to 50 times heads and very close to 50 times tails. So in these cases, the larger the data set that you're looking at, or the more often an experiment is repeated, the more accurate that probability is going to be. All right, we've got a second example here where you're going to calculate a probability based on data. All right, and what we're looking at is a number of births in the U.S. That were low birth weight babies. You've got the cutoff point. Those that were not, right, that were above that, and we want to calculate the probability that a newborn baby is in the low birth weight category. So we're going to start with the event, right, the number of outcomes that were low birth rates, 313,752, and we want to divide this by the total. Notice in this problem, we're not given the total. We're given a number that are low birth weight and a number that are not low birth weight. So I'm going to have to get my total here by adding up the number in each individual category. All right, so if I put these two together to get my total, right, my overall total, which is what I want to choose from, and then to get my probability, I'm just going to divide and I'm going to report my probability here at 0.0827. And remember, probabilities can always be interpreted as a percentage. So if I were to move the decimal 2 places to the right, what this is telling me is about 8.27% of the time we have a baby born with a low birth weight. All right, now when you're working your homework in ALEKS, it's typically going to want you to enter your answer either as a decimal or as a fraction. But I'd just like to point that out because it makes these things make a little bit more sense in terms of what we're actually finding. All right, so again, we've got one where you're going to check and see how you're doing. So pause the video, try this one yourself, and then come back and check to see if you're working it correctly. We've got 100,000 voters in a city. We take a simple random sample of voters, and we get 513 that support a bond issue, and we get 487 that oppose it. And we want to find the probability that a randomly chosen voter supports the bond issue. So again, we start with our event, right? The number that support the issue is 513. And then again, notice you don't have the total here. You have a number of people in each group. Now, once again, this one told me that I had 100,000 voters. But notice because this is a sample, right, my total is not actually 100,000. If I put these two together, 513 plus 487, I get a total in this sample of 1,000. And that's what I need to divide by to find my probability. So the big thing here when you're using data is just always make sure that you're dividing by the total, which typically is going to require you to add things together when they're split up into different groups.